Good morning, this is your Stats Sensei, Mr. Spensei, and this is Death Packet on chi-squared and regression. This will be problems 41 to 50, and we will be focusing primarily on regression. So data on ages and years and price in $100 for 10 cars of a specific model result in the regression line. Price equals 250 minus 30 times age, the number of years. Given that 64% of the variation in price is explained by variation in age, what is the correlation coefficient? So first off, 64% of the variation. This tells me that this section right here is my R squared or coefficient of determination. So R squared in this case equals 0.64. My slope happens to be negative. All right, so I have a negative slope, which means my correlation coefficient, or R, is also going to have to be negative. So what I'm going to have to do is take the sine of the slope, which is negative, and then I'm going to have to take the square root of 0.64, and I just raise it to the half power. So, and that will give me R. So 0.64 raised to the half power is 0.8, put the negative in it, and I end up with a negative 0.8 for my R. My answer choice for 41 is the answer choice for 41 is B. '42. A study is conducted relating AP statistics exam scores to the total number of study hours for the AP statistics class put in by the students during the academic year, and the correlation is found to be 0.6. Which of the following is a true statement? All right, so this is the correlation, so this is R. And R just tells you the strength of the relationship and the direction. So we know it's positive. So as one increases, the other increases. All right. Um, and on average, a 40% increased study time results in that? No. On average, a 60%? No. We can't tell that. It just tells the strength of relationship. It doesn't help us with prediction. 60% of a student's exam score can be explained by the number of study hours. That would be the definition of R squared, or the coefficient of determination. But the coefficient of determination is 0.36. So our R squared is 0.36, which is not what they gave us. We're working with 60%. So that's wrong. All right. 60% of the variation in exam scores can be explained by this linear model. Once again, we're dealing with the R squared. But what we can say is higher exam scores tend to be associated with higher number of study hours. And the reason we know that they're both going up is because this is a positive 0.6. So as one increases, the other increases. So the answer to 42 is E. 43. Jacques, an artisan cheesemaker, collects data on every step of the cheesemaking process. For each batch he makes, Jacques notices that the daily high temperature in his shop on the day he makes a batch of cheese was related to the pH of the cheese the next morning. He computed the correlation between the daily high temperature and the pH of the cheese to be negative 0.64. All right, that means they're moving in opposite directions. As temp goes up, pH goes down. And I know that because this is a negative, and I know I hit it, but this is a negative 0.64. Because the direction is negative, they're moving in opposite directions. All right. So, what information does the correlation provide about the relationship between the daily high temperature and the pH of the cheese? The relationship is linear. No. We can know that from a residual plot, not from the correlation coefficient. The relationship is not linear. Once again, we can only know that from a residual plot. The morning pH of the cheese tends to be higher when the daily high temperature in the shop is warmer. No, as the temperature goes up, the pH goes down. So if the pH alternatively, we can say as the temp goes down, the pH goes up. So tends to be higher when the temperature goes down. No, I may have just misread that. Hold on a second. Yeah, I read it correctly. All right, the morning pH of the cheese tends to be higher. All right, so it tends to be higher when the daily high temperature in the shop is cooler. That's true. All right. So when the pH is up, when the temperature is down. So that's my best answer to 43, which is D. All right, 44. A linear regression analysis relating secretary salaries to the years of experience yields y hat equals 19.78 plus 2.405x, where x is the years of experience and y is the salary in thousands. Which of the following is a proper conclusion? A starting secretary will earn 19,780, while one with 70 years should earn 188,130. Well, what they did was they said, well, they went 2.405 times zero. All right. So that's part zero. And then they said, well, that equals 19.78. And they multiplied it by 1,000. Well, that's an average estimate. All right. On average, we would expect them to make that. To say that will earn, I don't really like that word. I'm going to put a question mark because I don't really like the word will, because it's we can't predict exactly. This is our estimate. Starting salaries average 19,780. All right, with bonus of 2,405 dollars every year. No, that's not bonuses. That's an increase in pay. All right. So as the years increase, the pay increases. So I don't like this one. There's a cause and effect relationship between, we can't tell that. Um, we can just say that there's a relationship. Starting salaries for secretaries average 19,780. They just took the 19, they put zero in here, and 19,780 is this each year, or experiences associated with an average extra of 2,400, and each year of experience is associated with an average extra of 2,405. Yes. Notice we're saying average. We're not promising you that. We're saying that on average, you're going to get an increase because it's a positive value. We have a positive value. So every year that you work, you're expecting to make another $2,405. So that's my best answer choice. I like D. A said the word will, and that made it bad. Okay. All right. Moving on to question number 45. Suppose the correlation between two variables R equals 0.28. What is the new correlation will be if 0.17 is added to all the values of the variable X, every value of the Y is doubled, and the two variables are interchanged. Wow, that's crazy. After you did all of those things, it didn't change. All right. So basically, adding a constant doesn't change it. We saw that earlier. Swapping the X and Y doesn't matter. Doubling it changes the scale, but doesn't impact the R squared. I mean, doesn't impact the correlation coefficient. What will impact the correlation coefficient is multiplying one of the variables by a negative. If you multiply one of the variables by the negative, we'll still have the same value, but instead of a positive 0.28, we'd have a negative 0.28. All right. Data are obtained from a random sample of adult women with regard to their ages and their monthly expenditure on health products. The resulting regression is predicted expenditures equals 43 plus 0.23 times age, with an R equal a 0.27. What percentage of the variation can be explained by looking at the ages? Well, R is 0.27, and basically They said what variation can be explained. This tells me they're looking for my coefficient of determination. And my coefficient of determination is r squared. So I need to find r squared. So we're going to go 0.27 and we're going to raise it to the second power. 0.27 raised to the second. And we get 0.0729. And as a percent, that's 7.29%. All right. Suppose the correlation between two variables is 0.85. If each of the variables is multiplied by -1, which of the following is true about the new scatter plot? All right, so we multiplied both of them, which is interesting. When we multiply by one of them, the direction changes. All right. Oh, if we each of the y variables, we just multiplied y. So if we're only multiplying y, if we multiply y and x, nothing changes. But when we multiply by just the y by -1, we're going to have well, first off, a positive 0.85 is going to look something like this, going up like this, all right? But when we multiply it by negative, we're going like this. And we're going to end up with a negative 0.85. And we can see that this was a positive 0.85. This is positive and heading up. So negative is sloping down and to the right. So our best answer choice to 47 is B. 48. The least squares regression model y hat equals 0.34 plus 0.52x and correlation coefficient 0.66 were calculated for bivariate data with variables x and y. Which of the following is close to the proportion of variation that cannot be explained? All right. So this is tricky. All right. So first off, let's find the proportion of variation that can be explained. Well, if R equals 0.66, let's find R squared. R squared is going to equal 0.66 raised to the second power. And that gives me 0.435. So R squared equals 0.4356. Well, that's the proportion that can be explained. So the proportion that cannot be explained is going to be the complement. So 1 minus 0.4356. This is a proportion that can. This is a proportion that cannot. So 1 minus 0.4356 gives me 0.5644. And it looks like my best answer choice for 48 would be C. 49. A teacher collected information from a class of 25 students about the time and hours they spent studying the previous week and the time and hours they spent on the internet the previous week. The value of the correlation coefficient between the hours spent studying and the hours spent on the internet was negative 0.72. If the teacher changes the units of each variable from the hours to minutes, what will be the value of the correlation? You change the scale, the correlation doesn't change. So we're going to still say that 49 is at, or this is still at negative 0.72. Even though you change the scale, the correlation doesn't change. All right. So 49 is B. Moving on to 50. Jordan is working on a business model for a sandwich shop. Based on past data, he developed the model N equals 150 minus 3P, where N is the predicted number of turkey sandwiches in one day for a price of P dollars. Which of the following is the best description of the slope? All right. So let's take a look at that slope. And with our slope in this case, we notice we have a -3. And please remember, let's start off with this. It's always y over x. So in this case, it's the number of sandwiches sandwiches over the price. All right. So we notice it's negative. So as price goes up, sandwiches goes down. All right. And we have a negative $3. All right. So for every $3 increase in the price of the sandwich, the number sold is predicted to decrease by an average of 150. No, that's not right. And remember, this number is always one. So negative 3 sandwiches for $1 increase in price. So for every $1 increase in price, as this goes up, the number of sandwiches go down by 3. So for each $1 increase in the price of the sandwich, the number sold is predicted to decrease on average by 3. Predicted on average, I like this answer. All right. So our best answer for number 50 is C. If I look at this one, for each $1 increase in price, that's my X. The number sold is predicted to increase. That's what's wrong there. All right. For each increase of $3, no, we're talking about increases in $1, decreases the number of sandwiches by 3. Because remember, our X value is always going to be assigned as 1 when we do our slope. Okay. So hope that helps. Look forward to seeing you on the next one. Thank you.